And our expert today, Professor DeFries has an extensive biography, and I will not detail that, but I have selected a few flowers that should serve as proxies of its merit, which is to illustrate the caliber of our guest. Professor DeFries is professor at the Columbia University in New York. She is the co-founder dean of the Columbia Climate School, member of the U.S. National Academy of Sciences, and recipient of the MacArthur Genius Award, among many other scientific honors. And I want to underline this part. She's also an enthusiastic science communicator for broader audiences on states here the nuances and complexities of sustainable development, and also engaged herself in this very challenging field of trying to link science with policy that we all should anyhow do. And in her latest book, What Would Nature Do? A guide for uncertain times, she takes lessons from nature complexity to address current global social ecological challenges. And that's probably what is going to guide our conversation on what remains of the talk. And allow me a last detour here. Scientists, all of us, most of us, were sourly criticized in the last years, especially after in the post-corona times, by our inability to communicate to non-scientific audiences. And that's fair to say in this situation when we have one exception that confirms the rule. Professor DeFries is one person who is prestigious, talented, well, globally recognized scientist, but he's extraordinarily talented also to communicate science to non-scientific audiences. In this book, what you see now on your screen, What Would Nature Do? It does not only teaches scientific facts to lay audiences, but explains the scientific principles that could be uptaken by all of us to foster more sustainable practices and policies. All that written in a friendly, beautifully, and empathetic manner, avoiding these sophisticated lucubrations, technical jargon, and self-sufficiency that sadly characterizes most scientific writings. And my last starting point, What Would Nature Do? Is a book about complexity and systems, the premises, concepts, and operation. You will find there feedback loops, adaptive cycles, networks, all these things that we know from system science, but they are told with the grace and friendliness of I've detailed it above. What an insider, what I consider myself, I think a great achievement. After that, now my first question for you, Professor DeFries. How did you come with the idea of such a project? How this book come to your mind? In which circumstances was your book conceived?
Yeah, well, first of all, Daniel, thank you so much for the opportunity to be with all of you, and thank you all for joining. And thank you for indulging in this idea that we can have a conversation. I know we've all been on so many Zooms and webinars and presentations and PowerPoints over Zoom, and it gets very boring. So we thought what we would do is try something different and just talk and have a conversation. So I hope that that works for all of you. So, and thank you for that very kind and generous, a little bit overly generous introduction. And how did I get to this, to write this book? So we live in a world where we're so full of complex, wicked problems, and over again we see this attempt to try to find a silver bullet solution or a sort of reductionist approach, as you had in that nice graphic, and we see that over and over again. We see this with, for instance, the Green Revolution, which is where I started thinking about all of this in relation to the previous book that I wrote. So the problem is people don't have enough food. what's the simple solution? Grow more calories. And then we know this cascade of problems that comes from that. A more current day example, planting trees to sequester carbon from the atmosphere. Seems like a good, simple silver bullet solution idea, but ecosystems, as we all know, are very complex systems, and it's not so easy as just putting saplings in the ground. They need water. They need people to take care of them. There's land. There's all kinds of complexities that come around this. So over and over again, we see this kind of reductionist kind of thinking to address complex, wicked problems. So that had me thinking about the wonderful field that you all work in, complexity science. I can't claim to be a complexity scientist from the very mathematical side of it, but the ideas are just so incredibly important and beautiful. The idea of feedbacks and networks and nonlinearities and how complex systems work and the unpredictability, which is the crux of the issue here. And these concepts are so wonderful and important. They're very abstract. They're very, there's lots of jargon, as Daniel said, around these ideas, and it's very hard, as important as these ideas are, to relate that to someone outside of the field. So that was my challenge to myself: is can I write something that takes these amazing ideas and makes them tangible and understandable to someone outside of the field? So a way into this is with nature. So there's nothing more complex than nature itself, and we all depend on nature, and many people can relate to nature. So that was how I framed this: is thinking about nature as a complex system. How does nature survive as a complex system through all kinds of shocks, asteroids, wild swings in climate, all kinds of insults, but nature has survived for billions of years, millions, and very, very long time. So how? What are those principles of complex systems that have enabled nature to survive? No, there's not, as you all know, there's a lot of work on biomimicry with this idea that we have a lot to learn from nature. Really fantastic work about learning from spider webs and how to make Velcro and all kinds of wonderful technologies that have come from looking at nature in this field of biomimicry. This is somewhat the same idea, but in relation to the systems level, the how nature and ecosystems function as systems and what we can learn from nature, because nature has been very successful in surviving over so long. And then I wanted to think about these principles, and this gets really hard, and I hope we can have a good discussion around this. Think about how these principles of complex systems apply to human decisions, apply to our governance, apply to our current world and our civilizations, and in some cases they do, in some cases they might not. So that's just how I got to it, is through appreciation for the work that you do on complex systems and trying to make that more tangible through different stories and through using nature as the example of a complex system.
And going down to
thing I want to say, another thing
Yes.
I want to say about that is I was submitting the manuscript, literally, the final manuscript, literally that week in March when COVID came upon us and we started with all the lockdowns. It was exactly that same week. And then, obviously, all the network issues and the trade issues and the supply chain issues, they just really came barreling along with that whole COVID situation. And then I had to go back in and put a few more things in about COVID. But it was kind of ironic that I was submitting the manuscript just as the lockdowns were starting.
I thought I knew that COVID played a role in your writing, but I did not know that role. Anyway, I want to ask about, let's go a little bit in matter. You mentioned feedback loops, but as I said, not explicitly or not always explicitly, but you did a very nice metaphor. You used the metaphor of circuit breakers. And that's, I think, the second or third chapter on that. Could you please explain us, and yeah, as you did in the book very nicely, how some examples about how those circuit breakers operate, and how, more importantly, maybe how can we extract those examples beyond the metaphor to something that could be applied in real life, or with real examples that we have many or plenty of them nowadays.
Yeah. So the feature of complex systems of nature of being self-correcting is I wouldn't say self-correcting, self-regulating is an idea that I wanted to get across. That's the one of the first chapters. And here there's so many amazing examples for how our planet operates on so many different scales that use this or function because they can be self-regulating. So the global carbon cycle is a primary example of self-regulation, where if the temperature gets too hot, then there's more evaporation, so there's more rainfall, which pulls more CO2 out of the atmosphere, which leads to cooling, which leads to more then if it gets too cool, the opposite occurs. So there are these beautiful examples of self-regulation at that global scale. There's also all kinds of different examples of self-regulation in our physiology, like the way our bodies regulate blood sugar with insulin, and then the example, of course, of the leaf veins, which is the example of redundancy here. And this comes from work of some really great work of some physicists to map out how water and sugars move throughout leaf veins. And what we see is, as you can see from the cover there, that leaf veins are very loopy. They just fold back on itself, and there's many different ways in a leaf to get from through the veins to get from one point to another point. So that seems like it would not be a very efficient way for a plant to use its resources. But what evolution tells us and what nature tells us is there is an advantage to invest in that redundancy in the network. Otherwise, why would evolution have selected for that? And the advantage is quite obvious, that if there's an insect that takes a bite out of a leaf, then there's a way to go around. Like when you're stuck in a traffic jam, you're always looking for different routes to get around. So having that redundancy of having options, if something, there's some disturbance or some way that the network gets blocked, is something that we really learn from nature. And one of my favorite stories in the book is about the internet and the story of Paul Barron, where at very early days, pre-internet, the scientist working for the Rand Corporation had this idea, and this was in relation to defense, about command and control centers. Like how do you distribute those centers? So the current thinking was you have a central command. His idea was that that's very fragile. That's very dangerous. This is a Cold War story. That's really dangerous, because if that central command center gets taken out, the whole network comes down. So he had a whole lot of analysis and theories around decentralized networks and how that could be more robust to attacks. And he was just, when he was young, he was just laughed out of the room when he presented this to in some boardroom, and it was just seen as not efficient, not practical, didn't make any sense. But in the long run, that thinking is what makes the internet possible, is to have this redundancy in the networks and this decentralization. So that idea won out over the long term. And then, of course, we have so many, networks in the world that we live in. The global food trade, such a important aspect that we're all quite, always should be thinking about. And I know that a lot of people do really good work on that. And then another example that came along, this was after the book came out, was that barge that got stuck in the Suez Canal. Remember that? When the ships had to be routed way around the Horn of Africa. So that's another example of what happens when you have too much of a centralized network. In that case, there was a way around. It cost something, but it was around. And also another example being the wheat from Ukraine during the Ukraine war. That's another thing that happened after the book came out. So we see tragically what happens, hoarding and increasing prices, and really a lot of hardship around the world. So the way our the global food trade system has evolved, it's evolved to be really pretty highly concentrated, with a few production hubs, like in the Midwest of the U.S., in Russia, in the Pampas of Argentina, a few places in the world where so much of the world's food is produced, and then so many countries are relying on the imports. And we're seeing the sort of fragility of that kind of centralized network, with a lot of discussion around food sovereignty and decentralization. And in fact, there's been some recent interesting work that shows that the global food system has become less less hubs, less centralized than it's evolving to be less centralized, and that certainly makes a lot of sense. So, how we apply this to our current thinking about networks and self-regulation, and that's something we'd love for us to discuss here.
Another thing that was fascinating in your book was about diversity, also in terms of redundancy. But you mentioned this tale that about the Biosphere 2 experiment in Arizona, if I'm not mistaken, which is a fascinating example. I knew as a child, as a teenager, about when the thing was launched and everybody was attentive what's going on, but I did not know the full story, how it ended and why it ended. Maybe that's a very nice tale that we would like to hear from you.
Yeah, I don't know if anyone has been able to visit. I've been out there, I think, twice now, and it is such a fascinating place. I really would highly recommend it if you're anywhere near in Arizona. First of all, it's beautiful in the desert, and the idea of Biosphere 2 was a Bass, who very wealthy individual from oil money, Texan, invested in this idea to have a enclosed, self-contained, Biosphere 1 being the Earth, Biosphere 2 being the place in Arizona, a self-contained place where they could produce all their own food, recycle their water, and a place where you could show that it would be possible to live, like being out in space. And it's so interesting to read the evolution of that. There are all kinds of ecological issues with with pests and not being able to produce enough food. But really, the most interesting aspect about it is the social aspect. So people being locked up in this Biosphere 2, people went in to the Biosphere 2, they got locked in there through rigorous selection process. But even so, the social breakdown is really interesting, and then the management, and then it just it just kind of fell apart over the long term because of management problems. And actually, Steve Bannon's brother was involved in this, and Steve Bannon himself was involved in this. It's just, and then Columbia University, my university, managed Biosphere 2 for some time. And now it's a kind of a research site. But what it shows us is it is pretty hard, and if not impossible, to recreate a closed ecosystem that can provide food, water, everything that our planet provides for us. And then the other interesting kind of social aspects that can people, how do people govern themselves in a situation like that?
Maybe
So it's a
following
cool
this up,
place, these domes in the desert. So it's fun to see.
it's maybe gain some relevance nowadays with these initiatives now becoming very popular about colonizing other planets, and some people do not scope the difficulties and the challenges that may imply, even to generate a second Earth, a second biosphere within the Earth, brought so many challenges. I mean, biophysical, but as you mentioned, social challenge, how it would be that to be replicated in a different planet with a completely different outer setting.
Yeah, I know. It's a bit of arrogance to think that that people could do that, but there's a lot of thinking around that.
Yeah, some crazy initiatives. Another thing, and I probably will be the last question I will ask about one of the several chapters you deal with these principles of systems and complexity, using the Earth as an example, is the resilience and the adaptive cycle. You call it the book cycles of renewal. And you propose that instead of rigid linear planning, which probably you can tell us a few tales about to exemplify this premise, this concept in real life examples.
Yeah. So this idea of complex systems that you all work with, um, the panarchy kind of idea, the over and over we see this in civilizations where we have a civilization, and then it dies out for some reason, and then comes back up. So we see this is such a feature of complex systems, are these cycles of adaptation, disturbance, and then adaptation, and then renewal. And um, and this is quite an important idea, obviously, in ecology and understanding ecosystems. So I'm old enough to remember when the dominant concept in ecology was about this climax ecosystem idea, that there would be pioneer species and they come in, and then after a disturbance, and then the sort of pristine climax ecosystem is the equilibrium. And then in ecology, there's been quite an evolution in thinking about that idea is rather outdated, that there really is no such thing as a climax equilibrium, that part of the system is disturbance itself that leads to these cycles of growth, and then disturbance, and then destruction, and then adaptation and renewal. So so how do we apply that to our thinking when we see in the world that we live in, there's so much thinking about linear planning? I mean, like, people want to know exactly what the outcome will be, and this whole, we always hear about, will this solution scale, and what's the outcome, and what's the metric? And we hear that over and over again about thinking that if you do A, then B will happen, B, then C will happen, C, then D, and then you'll get to the outcome. But in these complex systems that we're in, whether they're nature or human created, you can't really draw that straight line and have linear planning. And the people who came up with the concept of wicked problems, Weber and Routel, in the 70s, their idea was this, and they were urban planners. So they saw this complexity, which they call wicked systems. They saw this complexity in urban systems that, if you want to reduce crime, you can't just send in a lot of police officers and beat everybody up, and that's going to lead to the elimination of crime. I mean, that kind of linear thinking, they saw that doesn't really work. So they leaned into this idea and had this really nice paper about wicked systems, wicked problems. And it's very similar to the ideas that we're talking about here. So how do we build this? And it's hard because when you're sort of want some particular outcome, how do you get to that outcome? I mean, we know we want everybody in the world to have enough food. We know that we want everybody to have access to, prosperity. How do you think about getting there? Because we know from our understanding of complex systems that this kind of linear thinking isn't going to get us there. So how do we think about creating the kind of enabling conditions that allow movement towards positive outcomes, rather than trying to dictate from some central kind of thinking how that outcome will occur? I have an example from I work a lot in India, and the government had this program, good intended program, to get everybody latrines, like pit latrines, to do away with open defecation, people going into the fields it's a health issue, it's a safety issue, all kinds of reasons. So there was this enormous rollout, absolutely enormous rollout of this building latrines, a lot of money put into it. And now, at least where I've seen, maybe different in different parts of the country, but from what I've seen, there are latrines in pretty much every remote household in every remote village. It's very, very widespread. But I have yet to see one that is used for anything other than storage. So this really came home to me when we're talking about this with some, local village people, and their response was, yeah, well, we really like this, but we want to be able to design it ourselves. If we want a sink, we want to put a sink. If we want a different kind of roof, like not a tin roof that's so hot, we want to be able to design it ourselves. So if you give us that same amount of money, we'll do it. We'll do it ourselves, and everyone will do it in their own way. So that is kind of example of how if you give people the enabling possibilities to create their own solutions, then they can take that on in a way that will work for themselves and be more likely to have the positive outcome that you're looking for, rather than saying, okay, we're going to build exactly the same way for exactly every household, this kind of latrine. So that's just one of my examples. I don't know, you probably have other examples like that.
This is probably the main message of the book altogether, that one can, of course, identify those features of nature, that we observe how nature addresses complexity and bring to our social systems. I mean, in the 50s, there was this gentleman who coined this idea of isomorphic principles. So principles that govern not all type of systems, all type of realities, also natural, but also social. it's still to be seen that thing. But the examples of the topics you have chosen, the adaptive cycles, for instance, very powerful metaphor of observing all types of phenomena at different levels. One see that at cellular level, in astrophysics, in social systems, in ecology, in forests, as you have said. That's a really powerful example. That's a lot to learn. But beyond the metaphor, it's as the saying says, the devil is in details. So how do you think we can crack that? Where is the fine line where we can convert the generic metaphors into something we can apply? We need to combine what? Technical expertise with overarching wisdom, or it's enough to say, okay, I'm a systems thinker, I know things work in this way, and I can understand that. What do you think about it?
Yeah, that's such an important thing to think about, and I don't have a perfect answer. How we really take these concepts and make them applied in the real world. There is one example where this kind of thinking did have a big impact on policy. And that it's not a very current example, but it is an example of how this kind of thinking can break through into policy. And that's the example of the Garrett Hardin and Elinor Ostrom story. So Garrett Hardin, this is going back a bit. Garrett Hardin had the idea about, he wrote about the tragedy of the commons, that if people are allowed to sort of use common resources, that resource will get trashed. And he had examples of pastors and different kinds of examples. And of course, we see many examples of tragedy of the commons, atmosphere being one primary one. But Elinor Ostrom, who won the Nobel Prize in economics, came along and said, let me back up. So this tragedy of the commons, you'll see it so frequently in policy about taking common property, common resources, common land, and putting them under centralized management, following this idea that if we don't manage, if the government or whoever manages these common resources don't manage it, then it will get trashed. So that was a very dominant concept in resource management. And then Elinor Ostrom did some very amazing, obviously, she got the Nobel Prize work, groundbreaking work about how there are certain conditions where the tragedy of the commons is not necessarily a tragedy. There's a drama that plays out, and that they are examples of, and she documented many of these examples, of where people come together to manage their own resources and kind of govern themselves to manage their resources. She started out with examples from policing in Los Angeles and community policing versus, top-down kind of policing to show the success of community policing. She had examples from fisheries, from rice management, from all kinds of lots and lots of different examples where people self-organized to manage their common resource. Oh, another one in Los Angeles, where she was from, is about management of groundwater, where the groundwater users, the farmers, the utilities, and the different users came together to come up with rules for how much each can use. So then her idea became really so important in decentralizing management of resources. She came up with a set of design principles that enable this self-organization and self-governance to occur. And then that kind of overthrew, not completely, because the tragedy of the commons, you still hear that a lot, but and it sometimes is true, but her work on this, which is really a very complex systems kinds of ideas, really took hold and led to a whole change in policies around decentralized and enabling community management for fisheries and so on. I would love to have a discussion around that, about whether that idea is practical in the current world that we live in. But is very impactful work.
And very impactful indeed. Thank you very much, Professor DeFries. I think it's a good moment to invite some attendees to the meeting if they would like to formulate a question or a comment that we can follow up. I still have in my sleeve a couple of questions in case people get some courage to do that. But yeah, if somebody would like to participate. Yes, Tatiana, please.
Hello, thanks for sharing your work. I must confess that I am an ignorant because I didn't know you and your work neither. So sorry for that, but it's good that I'm learning about it. I just wanted to comment on the practical implementation of these ideas of complexity. And I was thinking a bit about the emergence. And in a way, like, I have the feeling that if we try to think about practical solutions, in a way, we are under the same paradigm of linear thinking. So I think sometimes it's a matter of the quality of the agency or the self-governance. And from my point of view, it has to do a bit or a lot with the values, with our values, no? And also I was thinking about these ideas of deep leverage points for transformation. And I remember that one day I was reading a paper that we need to rethink the way we are connected to nature, because in a way we are nature. And from there, from these values of the way we connect to nature, from the values, I have the feeling that these governance mechanisms that we need will emerge. But the basis are the values. This is something that I wanted to share.
Yeah.
Also because in a way it's related to my work, because I was like reflecting in my PhD thesis about this idea of scaling sustainable agricultural systems. And I was like, we need to reframe this idea of scaling, because what we need to do is to think about like deeper, to let like the mechanisms to emerge.
Yeah, thank you, Tatiana. I love that. I love that idea of trying to be too practical is falling into the same trap. That's a wonderful thing to think about. And I completely agree that when it comes to human societies, values is really where, if there are not, values, then there's nothing. And that I heard a talk by Eleanor Ostrom before she passed away, where maybe even her Nobel Prize acceptance speech, where she talks about the fundamental principle of her design principles and making that work in the real world is trust, is trust in people, trust that people know what is good for them. Like those women who wanted to build their own latrine. Somebody might say, well, they'll just take the money and have a party. But I don't think they would. I trust them to know what is right for them. So I think that's our fundamental value, is to be able to trust. And unfortunately, it's kind of hard in today's world, but we don't have to go into a doomsday spiral here with what's going on in the current world. But really fun. I totally agree with you. Values, trust. And your point about nature, yes, we can't survive a day without nature in the urban world that we live in, that it's very easy to disconnect and not see that connection. But ultimately, and we're seeing it now, we depend on water, we depend on food, we depend on air, we depend on all of these things so that we can live, and we will, for survival, have to manage those resources well. We will ultimately, I have faith that eventually humanity will manage those resources because our survival depends on it. The question is how much hardship occurs in the time it takes to adapt to be able to better manage those resources. Thank you for your comment.
Thank you very much, Tatiana, for the question. And I have a follow-up question. If somebody has a question, I will just reframe mine. Please, Franz, go ahead.
Yeah, thank you, Daniel. Sorry for not showing my video at the moment. But my question is it actually possible to disconnect from nature? And aren't we nature? So if we change our environments into urban environments, if we make mistakes like centralize too much or apply linear thinking, isn't that all part of the nature, which sometimes leads us to make mistakes and collapse and die so that we can reorganize? Isn't that necessary? So I was wondering whether the title, What Would Nature Do, doesn't create, an illusion that we are not part of nature and we just have to learn from nature in order to not make the mistakes we do. But we have to make those mistakes, don't we?
Yeah, thank you, Franz. That's really, really great. And yes, of course, we are part of nature, and we are nature, and nature is us, and we depend on nature. And so yes, and exactly what you said, that's part of this adaptive cycle of making mistakes and learning. So I think we are learning that these principles from nature, the principles that have enabled nature to persist, that would have maybe been a more accurate title, but it would have been too long. The editors would have completely nixed that. And the more accurate title might be what principles of complex systems have enabled nature to survive for billions of years. But that would have never made it. But absolutely, I completely agree. And I think we are learning, like we've seen in terms of this global food trade, that it does seem to be getting more redundancy in the network. And then after COVID, when there was so much about supply chains and networks and concentration of supply chains and not having enough toilet paper in the US, if you followed that story, and there was so much discussion about that there was a big focus on building more redundancy in the business world, building redundancy into supply chains. Now, the issue, this kind of drifts back and forth because efficiency is the guiding principle for businesses. So it's more efficient to have a non-redundant network, unless something goes wrong, like the pandemic. But there has been that learning. So I think the more often that we're seeing these, and it's very tragic that we have to live through pandemics and water shortages and price spikes in food, but we can learn. Hopefully we learn from that. And then it's also a question of how often those kinds of learning opportunities occur. If they occur not frequently enough, then there's short memory. So I don't know. I mean, I hear from people who work on infectious diseases, we really are not prepared for the next pandemic that comes along. So if they're too infrequent, then we miss the learning because of the loss of memory. But if they're too frequent, then we can never really fully incorporate that adaptive learning.
Yeah,
But I
thank you.
completely
Yeah.
agree with your
Yeah.
thought there that that's learning.
Thanks, Ruth. Thanks for the answer.
Maybe time will tell. So if we are alive still in 1,000 years, we are part of nature. If not, we will see. If there's another question.
Well, nature will be alive in 1,000 years, whether humans are the dominant in 1,000 years, probably. I don't know. Who knows? This is unpredictable.
That's
It's a
for sure.
complex system, but probably humans will still be the dominant species. But over the very long term, I mean, we had so much throughout evolution of different domination of different species and different taxa.
That's the case, yes. We have still a couple of minutes for a short question in case somebody else. Okay, that was really a fascinating talk. Thank you very much, Professor DeFries. We are extremely thankful. And besides the talk, I'm really containing myself to make my final question, if you allow me, but it will be very brief. It's only 2 minutes. It's about this. There might be, and that's my last question, there might be a few highly powerful and distorting agents in complex systems too. Now it's proven by reality. We have not seen that. If one would have asked it, I don't know, Mr. Wiener 50 years ago probably would say that's not possible. But now we know that a few agents can change the whole system very fastly and very aggressively. I will not mention names, but we know what we are speaking about in politics, in economics, and etc., trade, etc., etc. What do you think about these very highly distorting agents?
Absolutely. And yes, it's a very, very troubling time. I think about it, being from ecology side of invasives. So if you have an invasive species come in, can dominate and outcompete everything else and take over the whole ecosystem. Whether that is possible depends on the strength of the ecosystem and the diversity of that ecosystem, and whether, I mean, there are many examples where species come in from outside and they don't become invasives because the community and the ecosystem can resist being taken over, and diversity being a primary feature of an ecosystem that it is possible to resist an invasive. So an invasive only becomes an invasive when it actually takes over. So it's the strength of our. I'm not a political scientist, so I shouldn't even go here. But this is such a stress test on the strength of our institutions. We fortunately live where you are now and where I am now. There is some strength of the institutions, and this is an unpredictable, complex system, but that's how I think about it in terms of invasives and resistance to invasives.
Again, thank you very much, Professor DeFries. I have to read the last note of Franz, that's the feeling of all of us. Thank you also for not showing slides. I think that we have all enjoyed the conversation, and that was lovely, and I hope we can re-edit this experiment in our expert talks, this complex systems group. I thank you again, and I thank you all our colleagues who spared this hour to be with us today. Thank you, everybody, and let's see us sometime soon.